Assalamu alaikum. Can you all hear me? Okay, good. So just a second and we'll start. Okay, so is the screen visible to everyone? Is the screen clear? Like is the resolution fine? Okay, and do let me know if between the class, between the session at any time the resolution uh, goes a bit low or something, because I don't know, sometimes it happens. And Hamad, zooming in would be better. Maybe try full screen. So that would be. Oh yeah, I will zoom in once I start. So I'm just asking about the screen, the resolution. So I will be zooming in when I'll start the question like this. Okay, so uh, in yesterday's session we did a question that like took us a lot of time. And the purpose of that question, why I did gave it a lot of time, was because this was a very important question. If you can understand this question, like you've understood projectile motion, like I'd say 70-80% of projectile motion, you've understood it. Like you've got the gist of it. One thing which many were being confused about, so I thought I would just talk about this once more, one last time, is we have equations with us. For example, we have an equation s equals 1 over 2, 1 over 2 at square plus ut. Usually we write it as ut plus 180 square, 1 over 280 square, but I just wrote it the other way. So when we have these type of equations, they require some values from us. For example, they require the value of acceleration. Then they require us the value of the initial velocity, then the time taken, and they give us what they gave us by these three values. They gave us the distance traveled during this period. So there's this initial velocity, and then obviously there's a final time period. So they're like, whenever we apply these formulas, we apply them between two regions of time. So let's say if I apply the formula here, this would be 1 and this would be 2. So everything at 1 becomes my initial thing, and everything at 2 becomes my final answer. I could apply it anywhere, like these two regions. I could also apply it something like this, 1 and 2. So now everything at 1 becomes my initial value. So the value of the speed at 1 would be my u, and the acceleration is constant throughout, so it would be the same. The value of my speed at 2 would be v, and the time that I'm supposed to take, if v is required, the time that I'm supposed to take for this whole region 1 and 2 would be equal to the time between this whole thing. So I don't need to take the whole time, just the time between these two. So I guess this would be around something 0 0.4 seconds or something like that. So that's the case with all of these questions. The frame you use, or the 2 points, the starting and initial point you use, it's up to you. But whatever the starting point you use, the initial velocity would come from that point, and the final velocity would come from the ending point. The time would be the time between the starting and the initial point. The best thing about this formula is however way you use them, as long as you're using them correctly, so your answers would be correct. So like that's the good part about this formula or this thing is, so as long as you're using them correctly, you'll get the right answer. So it depends on us. What are my initial points, and what are my final points? I could change them however I want. So one thing which is very convenient for me to solve this whole thing was I took this point, which is time 1.25 as my initial point, which was my starting point. So this became my u, and I know u was 0 here. So this was my starting point, and then I took my ending points. At one instant, I took this to be my ending point. At another instant, I took this to be my ending point. So whatever ending points I used, the time was between the starting point and the ending point. So for one case, I used this time, which came out to be around 1.25 seconds. And for another part, I used this time, which came out to be 1.75 seconds. So depending on what my starting and initial points are, that's how I use my points. So I hope this part is clear. If it's not, feel free to ask questions. And by the way, I would like tell this once again. So it's up to you how you would like to interact. I would appreciate if the classes are as interactive as possible. So you can ask questions on chat, and you can also use the mic. I would appreciate if they're asked on the mic, like that would make the classes a bit more interactive than just asking on chat. But nonetheless, there are no restrictions, whatever is convenient for you. Okay, so now we'll do some proper questions of projectile motion. And today, as we decided last time, our classes would be for 1.5 hours. So projectile motion was something which we were supposed to do yesterday, and today we were supposed to do questions from equilibrium. But we'll give some time to this, around like a half an hour more to this, till 10:35. I think we'll just do this paper, and then we'll move on to projectile motion. Yes, today we'll just do the past paper. Uh, I told this in last class. The idea would be to do past papers, and the past papers would be arranged in such a way that if you use them, if you like do them, and you've understood what we've done in them, if you understood the concept, you'll be able to solve many other past papers as well. And if at some point I do feel the need to go into a little bit of theory, I would do so. Like whatever I just told you right now was not related to the past paper, it was related to the theory, how we apply these equations of motion. But yeah, answering your question, most of the time we'll just be doing past papers, but not any random past papers. Past papers which would help us in obtaining a better understanding of the topic. Okay, so this question, A resistance is negligible. Calculate the horizontal component of U. So U is the velocity, the horizontal component. Any idea how we'll do this? Anyone? Yes. 12 cos 50. 12 cos 50 would give me the horizontal component, and do tell me the values like as you go ahead. Vertical component would be U sine 50. So what would be the value? To tell me the values. Okay. Uh, can someone tell me both these values? 12 cos 50 and 12 sine 50? 7.71. I'll assume this is for the horizontal component. And the vertical component, 9.91. So this is the vertical component. Now the next part is show that the maximum height reached by the ball is 4.3 meters. They're just asking me about the maximum height, like how above the ground the ball goes. So that's just the vertical component. So for this, I don't need the horizontal component because they're just asking me about the vertical height. So I use this vertical component and I find the maximum height. So there are multiple formulas which I could use for this. One of the formulas would be V equals U plus AT. And like this formula would not give me any answers directly. There would be another way. So, but Another formula which I could use here right now, which would actually give me the answer, is ut plus 1 over 2 at square. And then there's another formula, v square equals 2as plus u square. So the information I know is the maximum height reached by the ball. So I know that the distance traveled is 4.3 meters, and I know that the initial vertical velocity, which I would write as u, is 9.91 meter per second. And I also know the final velocity, because at the maximum height, okay, so it's 9.91. Some are saying, someone just said it's 9.91, and two students told me it's 9.19. So can somebody just tell me, like, okay, so I'll just check it myself. It's 9.9, it's 9.19. Yeah, 9.19. Okay, so, oh, thank you. 9.19. 9.19. I know that if it's the maximum height, the velocity, the final velocity at maximum height is supposed to be zero. So I know this as well. I know these three informations, and using these three, I need to find what I need to. Yeah, I also know the acceleration. Acceleration, which is 9.81 meter per second square. And I'll take acceleration downwards as negative. That's my notation. It's up to anyone, whatever the notation they feel like. But if I'm taking initial velocity u, which is 9.19 as positive, then obviously I'm assuming that the upward direction is positive. So now, if acceleration is downwards, it's supposed to be negative. Or otherwise, if I change my notations, I'll have to reverse the whole thing. But just keep a notation for you and do things accordingly. Now, what I basically need is, I need to use the three values, these three things, and find the one in red. So I need to use my initial velocity, my final velocity, my acceleration, to find the speed, to find the distance. I can use these two formulas, but the way I use this is, this formula requires time. I don't know time. For time, I'll need to use this formula, and I'll find time from here, and then put time in this equation, and I'll then be able to find s. I could show this in this way as well, but it's a 2 mark question, and this calculation would be very lengthy. So I just leave this formula and go with the one that's next, this one. I just go with this formula, and I know v square, which is 0 plus 2 times 9.81 times s, which I need to show, plus u square. U square is 9.19 whole square. When I rearrange this, and by the way, this would be negative, rearrange this, s. Can someone just tell me the answer of s? S would be something around 4.29 or 8, something like that, which would, I'd say, round, which will get rounded off to 4.3 meters. So this is how we'll do this part. Is this clear to everyone? Yeah. Okay. So someone just said that they get confused on which formula they should use. And by the way, I would prefer, if it's possible, then send general messages which everyone can see. Don't send direct messages. It's up to you. There are no restrictions, but I would prefer that, because uh, in that case, when there's a direct message and I start answering it, only the person who asked it would understand what the question was and what I'm trying to answer. Others won't get anything. So this would be able to help others as well. Just give me a minute. I have this diagram, which I would use, which could explain, clear this confusion for most of you, which formulas to use and when to use those formulas. Just a second. Okay, so I'll just go back to some previous page. Basically, the key lies in this like diagram. Maybe take a screenshot or whatever. If it's like you can read what I wrote. So the answer basically lies in this. There are formulas involved, formulas which I have. There are 4, 5 quantities which are always involved in all questions of kinematics. The displacement, velocity which has the initial velocity and the final velocity, then the acceleration, and then the time. So there are 4 formulas for the equations of motion which I have with me. These are those 4 formulas. Now the thing with these formulas is this formula, the first formula has these 4 quantities, but it does not have displacement, which is S. So if I have these, like if I have any of these, any 3 of these 4 quantities, and I need to find the other one, I use this formula. So this is how like you decide. All there are 4 formulas for equation of motion, and the ones which I've circled in green, those are the parts which are missing in all of these. So if you don't know the displacement, there is no information about the displacement, and there's information about the final initial velocity, acceleration, and time. You use the first formula, this formula. And if there is like not no information about acceleration, but there's information about the displacement, velocity, initial velocity, time, you use the second formula. But we never use the second formula. We rarely ever use this. The reason is because you always know the acceleration. And then there are these other 2 formulas. Maybe like write these down or take a screenshot or whatever. So these formulas, this formula does not have v in it. So if I don't know v, if v is like something which there's no information about it, and I have these displacement, I know the initial velocity, acceleration, and time. Out of these 4, any one would be missing. So if I have 3 of them and I need to find the fourth one, and it's of these 4. So like if it's either displacement, if I have in any 3 of these 4 and I need to find the other one, I use the third formula. And if it's I don't know the time, I know the displacement, I know the velocity, initial, final, and acceleration, or I know any 3 of these and I need to find the fourth one, I don't know the time, then I use the fourth formula. So like maybe like make this graph somewhere or something which could help you. So if you note, all these equations of motion have something missing. So the first equation of motion does not have displacement. The second most equation of motion does not have acceleration. The third equation of motion does not have final velocity. The fourth equation of motion does not have time. So all these equations have something missing in them. And depending on what's missing, you decide which formula you're supposed to use. So coming back, when we're doing this part, we know U, V, and A. So the information we have is U, V, A. What we don't know is we don't know time. So if you could recall that graph or you like know this, the only formula that's suitable is this formula. So we just use this formula and we're able to find the displacement. So I hope this is clear to everyone. Uh, just okay. So now the next part is determine the magnitude of displacement PQ. We now need to determine the magnitude of displacement PQ, this whole displacement. And obviously, when there's a displacement which has an angle with the ground, so obviously it would have 2 components. It would have a vertical component, which would be, let's say, SV displacement, sorry, the horizontal component, which would be SH, and it would have a vertical component, which would be SV. So this Pythagoras theorem, the sum, like when we apply the Pythagoras theorem and find the sum of these 2 displacements, we'll get PQ, which is the actual displacement. So for now, we just know this final maximum height. We just found it out to be 4.3 meters. This is what we know. Now, the next thing is we need to determine the magnitude. So we need to find the horizontal distance. So for that, the formula for horizontal distance is we just simply apply this formula. It's V equals displacement over time. So this is the formula that we use. What could be the alternative to what? So V equals velocity equals speed, displacement divided by time. So if I multiply the horizontal velocity, the velocity which is horizontal by the time taken to reach point Q, I'll get the displacement SH. So this is how I'll get SH. Now, how do I do this? I know the horizontal component which I just found out here. The next thing which I don't know right now is the time. So I could use this formula and I could find the time. How do I do this? I know the vertical velocity at point Q. The vertical the I use these vertical components and I do this. So what's the vertical velocity at point Q? The final vertical velocity at point Q, it's zero. So I write zero. And then there's U. U is the vertical velocity at point P. So at point P, the vertical velocity was 9.19. And then its acceleration, which is negative 9.81 times T. So if I use this formula, I'll get T. Can someone tell me the answer for T? Anyone? Okay, so I just did this myself. Yeah, 0.94. 0.94 seconds was the time. And I used this time. I got time. Now what I do is I put time here. So I know the horizontal component. It is 7.71 times t, which is 0.94. And I get the displacement, which comes out to be 0.94 times 7.71. It comes out to be 7.25 meters. So 7.25 meters is the horizontal displacement. Now I just simply apply Pythagoras theorem, which is 7.25 whole square plus 4.3 whole square under root everything, and I'll get my displacement. So this is how we do these questions. The thing to note here is this: how I found this. I suddenly shifted to the vertical component. So if you need to find time, you'll probably need to shift to the vertical component. Vertical component, you use the vertical velocities, the initial vertical velocity, the final vertical velocity, the acceleration in the vertical direction, and time. And you get time. And I could now, like when you're done with these questions, like I always say that projectile motion questions of projectile motion are not something you're supposed to do wrong. Like you're not supposed to make mistakes there because you can verify it like in multiple ways. So now I get time t. I could use this time t and I could put it into this equation, and I'm supposed to get 4.3 meters for s. If I'm not getting that value, it means that I've messed up somewhere something. So like you can verify our equation. Why did I use Pythagoras theorem? Because I needed to find q. I needed to find pq. I needed to find this PQ, and what I knew was SV. I knew these things. This was 7.25 and this other was 4.33. 4.3. So I needed to find the value for the red one. So I used Pythagoras theorem and I got my answer. So I hope that's clear. So this question was a repeat. Okay, so this question was related to the first half, and now the other type of question you could expect in your exam is related to the second half. I'll do one question out of these two, and since we're done with it. The next one, I'll just expect that you guys can do it yourself or try solving whenever you get time. Okay, so this question, quantity, which of these are scalar and vector? So we know this, like if you're good in your theory, you know acceleration is a vector quantity, speed is a scalar quantity, so is power. Yes, it's 10:30 already. We'll do projectile motion questions till 10:45. So, oh, did I say 10:30? Maybe I think I don't know when I said 10:30. The class is supposed to go till 11:30. I hope that's not what I confused. Okay, so a ball is projected with a horizontal velocity of 1.1 meter per second from point A at the edge of a table as shown in figure 1.2. The ball lands on a horizontal ground at point B, which is a distance of 0.43 meters from the base of the table. Air resistance is negligible. Calculate the time taken for the ball to fall from A to B. So obviously the formula which I wrote above, this formula, like remember this. I'll use this formula once again. The formula is VH times T equals displacement in the horizontal direction. And obviously we don't have any resistive force nor any deceleration in the horizontal direction. So the horizontal component of velocity always remains the same. So times T equals SH. Now VH, we know VH, they've given us, it's equal to 1.1. So 1.1 meters per second times T equals this displacement 0.43. 0.43. So if I now use this, what do I get? 0.43 divided by 1.1. I get time equals to 0.391 seconds. So, yeah, 0.39. So this is what I get for time. Okay, so I was able to find the time. Now in the next part, use your answer in BI to determine the height of the table. Now I need to determine the height of the table using just the time. Like that's how they trick you. Like projectile motions questions, uh, if you like pay attention to it and think about it critically, you just need 2 and 3 values and you'll be able to find all other things, but just by using the equations of motion. So they just told me time and they're now asking me to determine the height of the table. So a way to do this could be, I know the time, so obviously I know the formula that I need to use would either be a formula that involves time. So it would either be the uh, formula which is v equals u plus at, either this or the formula s equals 1 over 2 at square plus ut. I need to find I need to determine the height, the vertical height. So I'll probably prefer this formula and then I need to know what I can see. So the vertical height, I know the vertical height. I need to prove this. I know the acceleration, which is 9.81. I know the time. I know the time. What's the time? I just found it out. It is 0.39 seconds. And then there's this initial velocity in the vertical direction. Can someone tell me what's the initial velocity in the vertical direction? And please not a direct message. 0. So I know the vertical velocity as well. In fact, this whole part cancels out. So I can just simply use this thing. S equals 1 over 2 times 9.81 times 0.391 square. So I'll get my height. And now, if you just look at the question on the right, it's the exact reverse of this. they've given you these heights, this height, everything. And now they're asking us what was the end result they asked us in this part. Okay, so the height is 0.75 meters. Okay, so the end result of this part, of this first part of this, the question on the left was, I knew the vertical, I knew these information, I knew the velocity, I knew the vertical, the horizontal displacement and the horizontal velocity. I knew the acceleration. I was able to find the time. Then I was able to find the height as well. In the next part, if you look, what they did now is they've given me the vertical velocity. And now they're asking me to find the horizontal velocity. So it's like the exact reverse. In the first question, I knew the horizontal velocity and I was able to find the vertical height through it. In the second part, they've given me the vertical height and they're asking me the horizontal velocity. So we just reversed this, the whole method that we just did. And maybe you guys can try this out yourselves. So it's May, June 2017, variant 2. So it's just the reverse, so I won't go through it again. Now this part, this is just similar to the above part, uh, just that this time, in the previous part, they just asked me about the height and the time. In this part, if you could read the statement, they're asking me the vertical velocity of the ball just before it makes impact with the ground at Q. So the vertical velocity just before it makes impact. Now I also know this height, I know the height, which is S. So I'll mark this out S. Then I know the initial velocity, which is 0, with the initial vertical velocity, which is 0. I don't know the time. I know the acceleration. And what I need to find is the vertical velocity. So these are my 4 variables that are involved. Now, if you could look back and compare it with the equation of motion, these 4 formulas come in only one equation, which is v square equal 2as plus u square. This is the only equation where these 4 things are involved. Any other formula you use, it will require you to find the time, which you do not have at the moment. So we use this formula. I need to find v square equals 2 times 9.81 times the displacement, which is 25, plus u square. U is 0. The although it does have a velocity which is 15 meters per second, but that's the horizontal velocity, and we're now referring to the vertical velocity because where all those other values are vertical values. So now what we do is we write u square, which is 0, 0 square. So maybe remove this sign and write an under root here. So this will give me the velocity, the final velocity before it makes impact with the ground. And the next part is show that the time taken for the ball to fall to the ground is 2.3 seconds. So obviously, I can now do this again as well. And this time I'll use this formula, S equals 1 over 2 AT square plus UT. In fact, you can use any formula right now because you know all the information about it except, yeah, we know all the information except the time. So you can use these 4 values to find the time. You can use any formula. So this formula is also applicable, as well as the formula V equals AT plus U. Either of these formulas would be applicable because we know all the information in whatever there is in these formulas. We know the displacement, we know the acceleration, we know the initial velocity, we know the vertical velocity. So use any of these formulas and you'll get the answer, which would be equal to 2.3 seconds. The next part, calculate the magnitude of displacement of the ball at point Q from point P. So obviously, I won't go through this again, but I know that the horizontal component of velocity is 25 meters and the vertical component is SH. Maybe I'll just tell how to do this. I know that the formula was VH times T equals SH. This was the formula. So horizontal velocity is 15 and the time I just took it out to be 2.3 seconds. It equals SH. So I can find SH. I know SV square plus SH square. I underroot this all and I'll get my displacement S. So that's how we'll do this question. So I won't go to the answer, but I hope this methodology is clear. And now the next part, the next type of questions. So there, if you could see, there are different type of, they're like different type of questions that have in the exam. So one type of questions would be just the ball going up vertically and coming vertically downwards, which is not projectile motion. Because projectile motion is mostly two-dimensional, and this is just one-dimensional. It is a projectile, and but that's not the typical projectile motion that we do. The next type of questions would be the first half of the question, like before the point or till the point, till it reaches its maximum height. That's the second type of questions. And then the other type of questions are from like the object is at its maximum height and now it's moving towards the right side of the projectile. And then sometimes they merge both sides. So it's a full-fledged projectile motion question. So now the part is the ball is thrown vertically. The ball is thrown with an initial velocity v at 60 degrees to the horizontal. The variation with time t of the vertical component vv of the velocity of the ball from time t equals 0 to time t equals 0.6 seconds is shown in figure 2.2. Okay, so they just given me the variation with vertical velocity v of the ball from time t equals 0 till time t equals 0.6 seconds. And just by looking at this, uh, can someone tell me what this gradient represents? Anyone? What would this gradient represent? Yes, gradient represents acceleration, and specifically the deceleration. So, uh, if you could find out the value, they've told me in the next part that acceleration, a resistance is negligible, meaning that it's falling freely. That's free fall, acceleration of free fall. So just by looking at this, if you find the gradient, it will probably be equal to 9.81 meter per second. Okay, so then coming to the question, complete figure 2.2 for the time until the ball reaches B. The ball reaches point B. Now what happens is my ball had a vertical velocity component which was very high in the beginning, and as it moved upwards and time passed by, there was deceleration with which decreased the magnitude of this V till eventually there came a point where V became equal to 0. And after this point V, the ball started to go downwards in a direction like this. And the magnitude, not the actual velocity, the magnitude started to decrease as we went further. So obviously, this point 0.6 represents the maximum height where velocity was 0. And the acceleration, the gradient is still the same. The gradient is same. Acceleration is still downwards. It's still negative. It's still the same. So we just extend this graph like this till wherever it goes. So that's how you just complete the graph. Now, calculate the maximum height reached by the ball. So there would be two ways to do this. The maximum height reached by the ball. One way to do is you use the typical formulas that we have, and just by looking at the graph, you know almost all the information that's required. The maximum height. So I could use the formula v square equals 2as plus u square. Or there's another way which is very convenient. The area under the curve or area under graph of a displacement, a velocity time graph gives me the displacement. So I could just simply find out this area, and this area would be equal to this displacement. Would it not be? So it would be just equal to this displacement. So I just multiply these things. So 6 multiplied by 0.6 over 2 area of this triangle. I'll get my answer, which I think would be something around 1.8 meters. I'm just guessing. I don't know the actual answer. The next part, calculate the horizontal component Vh of the velocity of the ball at time t equals 0. So obviously now when I know the horizontal component, do we know the vertical component at time t equals 0? It's 6 meter per second. I know the vertical component is 6 meter per second. Previously, when we were doing the previous parts, when we were doing this part, you all told me that the horizontal component was equal to v cos u, or u cos 50. Sorry, not v cos u cos 50, and vertical component u cos u sine 60. So I use that same thing again. I know that my initial velocity is, or the vertical component is, v vertical is equal to, was supposed to be equal to the velocity times sine 60, because that's the angle they've given me. Vv, I can already see from the graph, is equal to 6. So I can say 6 equals v sine 60. So if I rearrange this, 6 over sine 60 equals v. I'll be able to find v. And then I know that the horizontal component equals v cos 60. So when I find v in the previous part, I just plug a v here and I get my horizontal component of velocity. And that's how I do this part. And on figure 2.2, sketch the variation with time of VH. Label the sketch VH. So now I need to draw a sketch for VH. Now, one thing I know about the horizontal components is it is that they do not vary. So whatever the value is, if someone could tell me, that would be great. But whatever the value is, I just draw a straight line like this. And that would be my horizontal component, the variation of horizontal component with time. The value does not change and it remains a constant. Okay, so the next part, which I wasn't doing questions related to energy, but this is since related to projectile motion, and I find this part to be like something important, so I'll do this. The ball has mass 0.65 kilograms. Calculate for the ball the maximum kinetic energy. So the thing about maximum kinetic energy is, the maximum kinetic energy is at the point where the velocity is maximum, not the components of velocity, not the vertical component, not the horizontal component, rather the sum of the horizontal and vertical component, which you obviously get through by applying Pythagoras theorem. So the sum of both those velocity, the vector sum of both those quantities, whenever they're maximum, I'll have my kinetic energy maximum at that point. So this is something you all should know, that the maximum velocity of the graph is either at the starting point or at the ending point. So in this, at the starting point or whatever the point is. So if my graph, for let's suppose, was being extended like this, so the ball did went downwards. So this would have been my maximum velocity, point of maximum energy, maximum velocity. So it's like up to your intuition. How do you identify which point has the maximum velocity? It, in this case, the starting point has the maximum velocity, and since it's symmetrical, the ending point also has this maximum velocity. So we just found out P in the previous part and we apply it here, 1 over 2 times 0.65 times V square. We just find the answer. Why do we not use components? Can someone tell me? Why do we not use components for kinetic energy? Components of velocities for kinetic energy. Does anyone have any idea regarding this? Yes, kinetic energy is a scalar, and these components which we're talking about are vector components, are components of a vector quantity. So we don't use them. We just concerned with the actual magnitude, the resultant magnitude. So the resultant magnitude which we get by adding those components of velocity. So when we add those components, we get the magnitude. That's all what we're concerned with. We don't know what initial each individual components are. We're just concerned with what the total component is. Okay, so the maximum potential energy above the ground. So obviously the maximum potential energy above the ground comes at the maximum height. So the maximum height we already know it's equal to 1.8 meters. So mgh, mass is 0.65 times 9.81 times h. That's how we get this part. Okay, so this is basically the summary of all sorts of projectile motion question. This question is also a bit different. Uh, but maybe I'd suggest that you all try doing this yourself. It's October, November 2011, variant 1. I'll just talk about what's different about this question. The thing different about this question is Mostly projectile motion questions are symmetrical. The way the first half is, that's how the second half is. That's how the ball would be after it reflects. This time the case is different. This time the trajectory is different. So the first half of the projectile motion is different, and the second half of the projectile motion is different. So that's all the difference there is. So just how you did previous questions, you find the horizontal component, you find the vertical component, and you find the vertical height gained by the ball when it travels from S to P. Show that the time taken for travel to ball to travel from S to P is 1.33 seconds. That's how you do this. And then the next part, this is where the trick comes in. Everything before this is just how we've done it. This is where the trick comes in. Show that the velocity of the ball immediately after rebounding from the wall is about 4.6 meter per second. This is like the part which could trick you guys. So how it would trick you is, when you find this out, you cannot use any information which was part of this previous projectile except for the time. So the time would be the same, except for the time you can't use any information from previously, from before like it hit the ball. So we found out the time which they've given us in one. I'm just giving an overview so that when you guys start do this question yourself, you'll have an idea. So we'll just use this time. The only thing we can use from the previous projectile, the first half of the projectile, is time. We can't use any other quantity. So we know the time, we know the height. uh, by using all these quantities, we can show that the velocity after rebound is supposed to be 4.6 meter per second. So that's how we'll do this. And then the change in momentum of the ball as it rebounds. So we know the initial velocity, the initial horizontal velocity as it struck the ball. Yeah, one of the key points about the uh, one of the things that will enable you to solve this question properly is, at this point only horizontal velocities exist. There are no vertical components, because it's the point where the vertical velocity has just become zero, just like at this point. That's where the ball hits the wall. So we just have horizontal components of velocities. So the whatever the horizontal component of this velocity was, that's the actual velocity here right now. And whatever the horizontal component of this velocity is, that will be the horizontal component here. So using that, we can find the change in momentum. We know what the change in velocities was 4.6 meter per second was the horizontal component of velocity after rebounding, and before rebounding was the component which I found here. So I know the change in velocity, I know the mass, I can easily find the momentum. Sit and explain whether the collision is elastic or inelastic. I can tell this by just by looking at it. It's inelastic, but you can do it yourself as well. That you can equate the kinetic energies before the collision and after the collision. They'd be different, obviously, because there is a change in momentum. Like the kinetic energy before hitting is not equal to the kinetic energy that was there after hitting, so obviously they would be different, and we'd not be able to we can easily conclude that they're not elastic collisions. Okay, so this would be all regarding projectile motion, and there would be some questions that I would give you, so maybe mark them somewhere. October November 2015 variant 3. Try solving this on your own. These aren't those two-dimensional projectile motion questions. These are just one-dimensional questions. And then there's this another question which is May June 2015 variant 1. And then there's another question regarding projectile motion which is May June 2012 variant 2. So maybe mark these somewhere. And this would be all for projectile motion. And now we'll proceed to the next part, which is equilibrium. Okay, so Okay, so to start off with questions regarding this equilibrium, and these are also like some very important questions. I'll start off with this question, and the trick to do this question, like if you understand this, there would be similar type of questions which you could see in your past papers. If you can understand this and be able to solve this, you can easily solve all other similar questions uh, in your past papers, or even if they come in your exam. Okay, so to proceed, a uniform plank AB of length 5 meter and weight 200 Newton is placed across the stream, is shown in figure 3.1. And obviously they've given me its weight, and they've mentioned the weight in the center, meaning that that's the point where its center of mass or center of gravity is. A man of weight 880 Newton stands a distance x from end A. The ground exerts a vertical force Fa on the plank at end A. The ground exerts a vertical force Fa on the plank at end A and a vertical force Fb on plank at end B. As a man moves along the plank is always in equilibrium. So if you could recall what equilibrium is, equilibrium refers to two things. Uh, can someone tell me what those two things are? Anyone?
Resultant moment is zero, resultant force is zero.
Yes. Resultant moment is zero and resultant moment is zero. And someone just messaged me still and equal and opposite forces. Yeah, still meaning there is no moment, resultant moment is zero, and the resultant forces are also zero. So explain why the sum of the forces Fa and Fb is constant no matter where the man stands on the plank. So obviously the answer to this part comes from the first condition for equilibrium, that the resultant force must be zero. So for the resultant force must be zero, Fa plus Fb must always be equal to 880 plus 200 Newton, which is the weight of the man and the weight of the plank. So they're always supposed to be equal to this, which is 1080. So that's why wherever the man would go, he can stand over here at any point. The resultant force, uh, the F and FB, the sum of these forces would be equal to the force by the weight of the man in the plank. So that's why he may stand wherever he wants. F and FB, the sum of both these would always be equal to zero. So I hope this part is clear. Okay, so the next part, the man stands at distance x equals 0.50 meters from end A. Use the principle of moments to calculate the magnitude of FB. So we need to find the magnitude of FB, and there could be different questions in your exam. Depending on what they're asking you, you use the pivot accordingly. So right now they're asking me about the magnitude of force at point B. So there are like two ways to do this. One is the lengthier way, one is the easier, shorter way. But uh, assume a pivot for yourself. Since they're asking me just about FB, what I do is I use my pivot, take my pivot to be at point A, and consider FB to be a normal force. Now, if A is my pivot, there are some forces acting. The first force is being acted by the man. So this force is a distance x, which they've given me to be equal to 0.50 meters. So I could say, and this moment is clockwise. And the standard notation is you use a negative for clockwise and use a positive for counterclockwise, but it's up to you however you use this. Or I could say that clockwise moment must be equal to counterclockwise moment, whichever way you studied it or whatever way you use it, the answer would be the same. So clockwise moment equals counterclockwise moment. The first clockwise moment is due to the person, which is 880 Newton time 880 newtons times 0.5, and the second clockwise moment is due to this plank, which is 200 times the plank is exactly at the center. So I can say it's 0.5, 2.5 meters. This would be equal to the counterclockwise moment. So the counterclockwise moment is only due to one force, which is Fb. So I could say the counterclockwise moment would be equal to 5 Fb. So this is how we do it. You rearrange this, you divide this side by 5, and you'll get Fb. Can someone tell me what the answer for Fb comes out to be?
188 Newton.
180,
88.
188 or 1088?
188.
188 Newton. Okay. So 188 Newton comes out to be Fb. So that's how we find Fb. And now if I ask you to find Fa, how do we do this? So now there could be two ways to do it. Similarly, the second way also applies to Fb as well. So there are two ways to do this. What are the two ways? Is I know that the sum of Fa and Fb is always supposed to be equal to 1080 because they're supposed to be equal to the weight. So if I need to find Fa, I could just simply say Fb equals 1080 minus Fv, which is 188. So I could find Fa accordingly. So that's how I would be able to find Fa. That's the simpler way. And we could have done this the exact opposite way as well. Now, the other way is that we assume the pivot to be at point B. We assume the pivot at point B, and this moment becomes a counterclockwise moment. This moment becomes another counterclockwise moment, and Fa is the source of a clockwise moment. So these two moments in red must be equal to the moment in pink, and therefore, just how we did this, we'll get another equation that will give us Fa. So that's how you could even verify this. Like if you're in an exam and you have some time, try the other method and ensure that the answer is correct. These are projectile motion, and these equilibrium questions are not those questions which you're supposed to like lose marks in, because there are multiple ways to verify the answers. So like you'll be just wasting your marks. There are other questions which could be difficult, and there would be no ways to uh, there could be no ways to verify them. So maybe if you're going to lose marks, that's where you're supposed to do it. Okay, so someone is requesting transcription, but I think I won't be enabling them, enabling transcriptions because they like blur the screen. So I hope it's okay with the person. So obviously I'll upload this on YouTube, and if you really want, you could use those transcription by YouTube and like watch it there and then. Okay, so this is how I could find it. The other way was I could use the pivot at point B, and I could find point A. And similarly, like that's the whole way. I could either find point FB by assuming a pivot at point A, and then I would use FB to find FA. The other way could be I assume the pivot at point B, I find FA first, and then I use the value of FA, and I use this equation to find FB. So there are multiple ways to do this. Try these out in your exam and try these out when you're practicing so that you don't lose marks in these questions. Next part, the variation with distance x of force Fa is shown in figure 3.2. On the axis of figure 3.2, sketch a graph to show the variation with x of force Fb. So we just need to show this variation. The way we could use it is we know that the sum of both Fa and Fb is always supposed to be equal to what? Is always supposed to be equal to 1080. So if I look closely, this is if I look closely, this is 600, 700, 800, 900. This is 950. So the initial value of Fa is 950. I need to write the corresponding value of Fb. So what would be the corresponding value of Fb when Fa is 950? So sum of both of them is supposed to be 1080. and FA is already 950. So FB is supposed to be, it cannot be anything less than 130. So I just find 130 on my diagram, or maybe it's not 950, assume it to be 980 or something. So FB would be at this point when FA is at maximum. So when the person is at a distance of 0, FA is 980 or whatever it is, and FB is 100. Then at the final point, FB is what? FA is what? FA is 100. The sum of FA and FB is supposed to be equal to 1080. So obviously, this time the force FB is supposed to be here right now. It's supposed to be at this point, FB. So I know the starting and ending point, and I just merge these lines. So that's how I get FA and FB. But just make sure that you ensure that the sum of both forces at all points are equal to 1080.
Sir,
Yes.
could you explain this again?
This again. Okay, so the question was that the person was standing at a distance x, which they've given us here. The person starts to move, and he, like, the distance x, he moves a distance x from here to there, from A to B. So they plotted this distance of the person from x equals 0 till x equals 5 meter per second, meaning from when the person was at point A till when he reaches point B. Now they're asking me in the part is, in the actual question is to sketch a graph to show the variation with x of force B. So I just need to show the variation with x of force B, the variation, how force B varies with x. What I know, what I've like given them in part A is that the sum of FA and FB, FA plus FB is always supposed to be equal to 1080. So this is something which I know for sure. Now I look at different points on the person's journey. When the person's at point A, the value of FA, they've given it to me, it's equal to 980 Newton. Like I can look at the graph and it's approximately 980. Like this was supposed to be 950 and it's somewhat above it. So I'm assuming it to be 950, 980. So it's 980. The force FA is 980. Sum of both these forces is supposed to be 1080 at all points. I don't know what's happening to this one note. Just a second. Sum of both these forces is always supposed to be equal to 1080. So if FA is 980, FB is obviously supposed to be equal to 100. So that's the only way the sum of both these would be equal to 1080. So the point when the person's at x equals 0, he's at point A, I locate my force FB, which is equal to 100. And then I just look at the extreme endpoint. At the extreme endpoint, when the person standing on point B. So when the person is at point B, FA is equal to 100. And obviously, I know the sum of both these forces is again supposed to be 1080. So I know FB is supposed to be 980. So FB is supposed to be 980. I now know both the points, both the extreme points of FB. So I know these points. I just draw a straight line and I join these. So is this now clear to you?
Yes, sir. Thank you.
Okay, so now coming to like a different type of questions when it comes to equilibrium. So this is the question. Define center of gravity, the point where the whole mass of the object can be assumed to be concentrated. That's a definition you all know. Okay, so now the actual question. A uniform rod AB is attached to a vertical wall at A. The rod is held horizontally by a string attached at B and to point C as shown in figure 3.1. The angle between the rod and the string at B is 50 degrees. As they're just explaining the diagram in words. The tension T in the string is 30 newtons. So this T is equal to 30 Newton. That's something they've not mentioned in the diagram. Use resolution of forces to calculate the vertical component of T. Can anyone tell me how do I find the vertical component of T? By resolving forces?
T theta.
Yes, V sine theta. And can you tell me the answer as well? 30 sine 50.
23 newtons.
23 Newton. And now the next part is state the principle of moments. So the principle of moment is actually about equilibrium, that an object is in equilibrium when the counterclockwise moment is equal to the counterclockwise moment. So when both moments are equal, the object is in equilibrium. That's the principle of moment. Use the principle of moment and take moments about point A to show that the weight of the object O is 19 Newton. So this is the important part. They've told me to take point moments about point A. So I'm supposed to assume point A to be my pivot. Now, if you all could recall the definition for moment or torque was force times displacement. And the thing about this displacement was that this is the distance, the perpendicular distance between the line of action and the pivot. So whatever forces I have right now, I'll be drawing the lines of action of these forces and the distance between them and the pivot. Okay. So I need to now use these moments and to show that the weight of the object O is 19 Newton. So what are the forces I know? One force I know is this 8.5 Newton force, which is the weight of the object. So the moment that this force, okay, so I'll make a table, clockwise and counterclockwise moment. So this 8.5 Newton, this 8.5 Newton gives me a clockwise moment about point A. So I start finding that. I find that, and it's 8.5 times 0.6. That'll give me the answer, which is the moment, counterclockwise moment due to this mass B. And then there's this mass O, which is a distance 1.2 meters. So 1.2 meters times the weight of object O. So this gives me the the clockwise moments. Then there's this tension. If I resolve this tension into its components, so one component would be this, and the other component would be this. So as you just told me, the vertical component is 23 Newton, and the horizontal component, I could find it through V cos theta, which would be 30 cos 50, and I'll get it to be equal to 19.3.
Sir,
Yes.
won't we be considering the vertical component only?
Won't we be?
The vertical component.
We
because
will
the
be
distance
considering.
Should be perpendicular.
Yes, we will be considering the vertical component. Yeah, that's what I'm coming to. That's what I'm coming to. Hopefully, that will be your answer. That will be the question to your answer. The horizontal force, this force, is straight to the uh, straight passing through the pivot. So there is no perpendicular distance between the line of action of this component to the pivot. So that's why we just ignore this force and we don't consider the moment. There is no moment due to this force about point A. So we just kind of ignore this. So we eventually end up using the vertical component. But if it was a point somewhere else, like if point A was somewhere here, then we wouldn't have ignored the the horizontal component. We only ignored the horizontal component because it was passing through the pivot and therefore it wasn't causing any turning effect. So that's why we did it. And now it's 23 Newton times the distance. The distance is 1.2 and this is a counterclockwise moment. So we equate all these things and it becomes 8.5 times 0.6 plus 1.2 W naught equals 23 times 1.2. Obviously, if we rearrange all this and solve, we'll get W naught and I could substitute W naught with mass of object times 9.81. So when I do that and I find m naught, it will eventually come out to be 19 newtons. Oh, sorry, they've asked me about the weight in this part. So yeah, I find the weight. And for the second part, the mass of the object O. So for that part, I'll find the mass through this. So I hope this is clear. Use the concept of equilibrium to explain why a force must act on the rod at A. Can someone tell me about? Can someone tell me this? Why is uh, there supposed to be a force acting on at point A?
For equilibrium to be attained, the resultant force and the moment should be zero. So there should be a horizontal component which should act to balance the forces shown.
Yeah, there should be a horizontal component which would be opposing the horizontal component by tension. So one to oppose this, and the other horizontal component is if you add these two forces. The other would be a vertical component. If you add the force due to the object O, the weight of object O and the weight of the plank, so it will come out to be 19 plus 8.5. This will be 27.5 Newton. And the upward for the down, so the resultant downward, the total downward force is 27.5, and the total upward force is 23 Newton. So there would be a resultant force downwards, which would be equal to 4.5 Newtons. So there's a resultant force downwards, and which should be counted by this as well. So there should be a upward force of 4.5 Newtons as well. So that's the reason why there should be forces. I just went into a bit detail. As for the question, you can just tell them that uh, there should be a force on A, force acting on the rod at A to counter the horizontal forces and the vertical forces on this plank, on this whole plank or plank or whatever they've called it a uniform rod. Okay, so rod test. So
because the horizontal component of P isn't balanced. Like that.
yeah, the horizontal component as well as the vertical component, both are imbalanced. That's why I did all this. Or did you get how the vertical components are imbalanced?
No, sir.
So what's the vertically upward force acting on the rod? It's 23 Newton, right?
Yeah.
And then there is a downward force acting on it, which is the sum of the force due to mass O and the weight, which is 8.5 Newtons. So it's 8.5 plus 19, meaning it will be equal to 27.5. So when there is a 27.5 Newton force downwards and 23 Newton force upwards, the resultant force would be 4.5 Newtons, which is downwards. So this force is also imbalanced. There should be another force on A which would counter this force because there is a resultant force right now. The resultant force is not zero. Okay, so this is again the same question got repeated. Okay, so this question is very similar to what we did above. So maybe mark the question number. It's May, June 2015, variant 2, and try solving this yourself. For now, I'll do this question. This question is, although again similar to it, but a bit different. So I'll just do it. Define moment of a force, the turning effect produced, etc. You can answer that question. A uniform metal beam. Okay, so I won't read this statement because they've like explained this whole thing. The graph is self-explanatory. They've just explained this figure in words. So I won't read this whole again. So by taking moments about A, show that TA is 2.1 kilonewtons. Again, a point A, and show that T is 2.1 kilonewton. This time, I don't need to resolve T in its components. The reason is uh, torque
It isn't
was
passing towards the pivot.
hmm?
It isn't passing from the pivot, so that's why we don't need to balance it. I mean, resolve
No.
it.
I didn't exactly understood what you were trying to say. It wasn't even passing through the pivot in this part. Was it passing through the pivot here? Was the tension, the force T passing through the pivot? No, it wasn't. But we still resolved it into its components. So the reason was why we resolved it into its components was we need force times the perpendicular distance between force and line of action. We didn't know this above. So this time, if this is T, the line of action for T could be something like this. This is the line of action for T. And there would be a perpendicular distance between the line of action and the pivot. This is the D which is required and the T which I have. In the previous question, the diagram is here. This was T. And this was the perpendicular distance between the pivot and T. I didn't know this distance. This wasn't known to me. So that's why I resolved this T into its other components, this component and this component, such that I know these distances. I know this distance and the other one cancels out. So that's the reason why we went using, why we did resolve this into components, and we won't be resolving this into its components. So I hope this part is clear to you. Is it clear?
Yes, sir. Clear. Thank you.
Okay, so this time I don't need to resolve this into its components. The moment due to T. So and what's the uh, direction of this moment? It's counterclockwise. So if I have this graph with me, so clockwise and then there's counterclockwise. So I could write this counterclockwise moment, which would be 2.8 T. This is one moment which I have. Now there are two other moments which I have. One is 500 Newton and the other one is 400 Newton. Now what I need to do is I just need to find these values. This perpendicular distance as well as this perpendicular distance between the pivot and the line of action. So I could simply do this in a lot of ways. I know this whole thing is 2.8 meters. So obviously, like I know this line is 2.8. If I apply sine to it, I'll get this component. This becomes a triangle, right? This is 2.8 and the angle is 30. So if I apply the trigonometric functions, I'll get this, which would be 2.8 sine 30. This is how I'll get this component. And then obviously I know that this 50 Newton, this 500 Newton is due to the center of mass, because if you could read it, it's the weight, and the beam has length 2.8 meters and weight of 500 Newtons. So if it's weight and it's acting at some point, that's the center of mass, which is at the center of the beam. So obviously this is exactly at the center. So for that, I could like easily locate this, like it's exactly the half of this. This point lies exactly in between the previous point. Or I could use another way is 1.4 sine 30. That's how I could find this, because it's exactly in the center of the pivot. So this is what I do. So the answer for 2.8 sine 30 was coming out to be, this was coming out to be 1.4 meters. So obviously if this whole rod, if this whole distance was 1.4, so 500 Newton, the 500 Newton force is exactly in the center. So that's 0.7 meters. So that's where the force is. So I just do this accordingly. 0.7, which is center of mass of the beam, times 500. This is one component of clock, which is the clockwise motion. And then there's another component due to the load, which is 4,000 times 1.4. Now I use this all, I equate everything. 0.7 times 500 plus 4,000 times 1.4. I use this, I divide it by 2.8, and obviously I get an answer. When I equate both moments, clockwise moment equals counterclockwise moment, I get 2125 equals 3. So, which is approximately equal to 2100 Newton, which is 2100 kilonewtons. So that's how you'll do this question. Now calculate the vertical component TV of the tension. So I do know the component, the total force T. So if I know the total force T and I also know this angle, it's 30, I could simply use this angle 30 to find the vertical component. Sit and explain why TV does not equal the sum of the load and the weight of the beam, although the beam is in equilibrium. So what they're asking me is, I'll just now remove all this thing to make this a bit clear. So what they're asking me is that this component TV, why is this component TV not equal to this force, both these forces in red, the weight of the beam and the load? Why isn't it equal to this? And the reason for that would be something very simple, is that it's hinged at point A, and obviously, so there's it's since it's hinged at point A, there's another downward force acting at point A, so TV must also be equal to that force as well. So that will be the answer for it. So I hope this all is clear. Try doing this question yourself. Now I'll just do another question, and this will be a last question for today. So a motor drags a log of mass 452 kilograms up a slope by means of a cable as shown in figure 2.1. The slope is inclined at 14 degrees to the horizontal. Show that the component of the weight of the log acting down the slope is 1070 Newton. The component of the weight of the log acting down the slope is 1070 Newton. So anyone having any idea how I do this? Okay, so we just apply the simple formula, which you all are supposed to know, that whenever it's an object like this, it's at an inclined angle. The formula is that weight equals, sorry, uh, this has two components involved. One is the weight of this block, which is acting downwards, and then there's another force which is acting on this direction. So if I label this as, let's say, B, and I label this as H, so I can say that V equals H sine 14. That's the formula we have. And H equals, sorry, not H sine 14, it's W sine 14. W is the weight. And H equals W cos 14. So that's how just we do it. So if you use this, V equals W sine 14. If we know weight, it's 452. So it's 452 times 9.81 times sine 14. We'll get V. It will be equal to 1070 Newton. And the next part is the log starts from rest. A constant frictional force of 525 Newton acts on the log. The log was supposed to move upwards. And since it was supposed to move upwards, the resistive force is always opposing motion. The resistive force is downwards in the direction of H. The log accelerates up the slope at 0.130 meter per second. Calculate the tension in the cable. So to find the tension, we need to sum up these forces. So for that, there is this force which is applied by the motor, and that force is supposed to be, or let's say the formula for forces are F equals ma. That's the formula that we have, where F is the resultant force. So for the resultant force, there are some forces acting. This is frictional F. And then there's a force due to this motor, which is acting upwards, which I could say Fm. So summing all these forces, I'd get my resultant force. So my resultant force would be Fm minus H minus F equals mass times acceleration. So I need to find Fm, the force due to the motor, and because the force applied by the motor would be equal to the force, or would be equal to the tension force. So Fm equals H minus F times A. So mass is 452 times 0.13 times, sorry, not times, plus h plus f, which is 525. I'm not solving this whole thing, but this is how we'll do this. Okay, so do this and you'll be able to find Fm, which is force by the motor and which is again the tension force in the cable. The log is initially at rest at point P. It is pulled through a distance of 10 meters to point P. Calculate for the log the time taken to move from S to P. So obviously I won't now do this part, these questions. These are part of the projectile motion part. They've given us the distance. We know the acceleration. We know the distance. We know the acceleration. We know the initial velocity equals 0. S equals 10. And we don't know V. We know acceleration equals 0.130. So we could just use this information and find time. So the formula most suitable for this could be S equals ut plus 1 over 2 at square, where ut becomes 0 and acceleration would be in the negative direction because sorry, no, acceleration and s would be positive, so it would come out to be something as 10 equals 1 over 2 times 0.130 times t square. So you can find t by this and you'll get the answer. And then the magnitude of velocity p, so we now know the time, so v equals u plus at. We know the initial velocity, it was equal to 0. Acceleration, we know the time we just found out, so we could just draw it. So this is where we'll end this session for today. If anyone has any questions, feel free to ask them. Otherwise, we'll just end it.
Understood, sir. Thank you so much. And,
Okay, so no questions, and we'll end it for today. And
sir,
inshallah tomorrow. Yes.
what topic we'll be doing tomorrow?
What topic? Just see the schedule. I don't remember what topic it is, but whatever is in the schedule, that's what I'll be doing.
Okay, thank you, sir.
Welcome. Assalamu alaikum.
Allah Hafiz.